Welcome back to Python by example. This is session 4. And just as a reminder, if you have not yet watched sessions 1 to 3, I strongly encourage you to do so, as the concepts that we would have covered in those sessions are going to be applicable in terms of having a full understanding as to what is about to transpire. So we have our practice sheet, and in this session, we are going to work through a few examples together. So let us start at this scenario where we are being asked to build our own computer using the Python command. The instructions are as follows. The calculator should ask the user for two numbers. Then it should ask for the operation they want to perform. And we are given a list of operations here. And we need to use multiple if statements to determine which operation to execute. So we are back inside our editor. And it says that we need to accept two numbers. So that's what we're going to do first. So we need to declare our variables. So let's call it num1. It's going to be an integer. So we know we need to use our conversion operator or our conversion function in. And we want the user to be able to enter data values. So we are going to be using the input command. Let's place our prompt. So enter num1, colon and a space. We're going to do something similar for num2. So let's just save some time by copying, pasting, and doing the necessary modifications. So we have allowed the user to enter num1 and num2. And because we like to test as we go along, we are going to write a print statement using the formatted print operation. And we are simply going to display num1 and num2 just to ensure that those two lines of code is actually working properly. So we're displaying num1 and we are displaying num2. And we're separating them with a comma. So let's execute. So it says enter num1, we enter 10. Enter num2, we enter 5. And we are seeing 10 and 5 being displayed on the screen. So it means that our input statement is working as we anticipate. The question also asks us to prompt the user for the operation they want to perform. And we are given a list of operations. So let's go ahead and do this part of the code. So let us create a variable called upper that we'll be using to store the operation. And because we are expecting symbols, we can just use the input statement without any conversion. So enter operation, colon. And it's customary in cases like these to have a list of the operations which are permissible. So we have the plus, we have the minus, we have the division, we have the division, we have the division. So please note that there are several operators which are going to be used as division operators. And if we look at our arithmetic operations, we can see them listed here. And we'll talk about the differences between these operators as we build out the program solution. It also asks us for the multiplication sign, which is a simple single asterisk. And it also asks us for the exponent symbol, which is double asterisk. So we need to include those as well. All right, so there we go. So let's also print the operator. And let's test again. So 10, 5, with the operation being, let's say, the plus. And we are displaying the 10, the 5, and the plus. So once again, our input statements are being accepted. Now we reach the fun part, where we are being told to use multiple if statements to determine which one of these operations we want to execute. It therefore means that we now need to be using our if statement. So, because it says multiple if, then we will be setting up our multiple if statement construct. We're testing if upper is equal to a value. Let's say that the value is the plus operator. And if the value is the plus operator, because we're doing a calculator, then we would want to do the plus operation. So that would be num1 plus num2. We need something to store our result. So I'm going to create a variable called result at the top. And I'm going to update that variable. The result is assigned num1 plus num2. Please note that line 9 is actually linked to line 8. In other words, on line 8, we have our if statement. And line 9 is what is going to be executed whenever line 8, the if statement, is actually true. And that's the reason for indenting line 9 so that we can link it to the if statement. So this is something we would have covered in our previous videos. We're just highlighting the concept here again, just as a reminder. Using another if statement, we're now checking if operator is equal to minus. And in this case, we know that the result is going to be num1 minus num2. And it makes sense for us to display the result. So let's have the result being displayed inside our print statement. So this is enough for us to actually test to see if our logic so far is going according to plan. So let's clear the output. Let's re-execute. I have a syntax error. And it means that I have left off something. It says that it's expecting the colon. And I have not placed the colon where it should be. So if we go back to our code, looking at line 10, you realize that the colon is indeed missing from the end of the if statement. So let's clear the output. Let's re-execute. This time it executes, meaning the syntax so far is indeed correct. So we're entering 10 and 5. And let's say that the operation that we select is the minus operation. Then it means that the result should be equal to num1 minus num2, which is 10 minus 5. And our result, therefore, should be 5. So let's enter. And we have 10 and 5, which are the inputs num1 and num2 respectively. We have the operator being minus, and then we have 5 being our result. So just to make it clear, let us enter 10 and 3, where we know that the output is going to be 7. We do the subtraction. And here we have our input num1 and num2. We have the operation, the minus operator, and we have 7 as our result. So we're now going to test the plus operator. So 10 and 5, we select the plus operator. We enter, and we end up with our input, 10 and 5, the operator, which is the plus, and our result, which is 15. 10 plus 5 gives us 15. So let's continue building out our calculator. And we're going to use the common operations first. So we have the plus and minus already working. So we want the multiplication and the division. So let's do them in that order. So I'm going to copy and paste. I'm going to use the multiplication in this scenario. And then I'm going to also use the division. And it's now time to test. So we execute. Let's enter 10 and 3. The operation this time is going to be multiplication. And our output tells us that we have 30. So 3 times 10, that's 30. So let's now check the division. So it's 10 and 3. And this time we use the division operator. And we hit enter, and we realize that we're not getting what we anticipate. By the way, let me just do that again, because I pressed the enter key way too late. So it's 10, it's 3, it's division, it's enter. So we enter 10 and 3. We are using the division, so we are dividing 10 by 3. And we end up with 3.33333. And this tells us that our output at this stage is going to be a floating point or a real number. And that's what we are seeing in terms of the display. Now, I did mention that we have several operators that perform division. That was the first one, and that is the normal division that we are used to, where when we divide, we end up with the real number or the decimal point to indicate that there is a remainder whenever we have done the division. So if we divide 10 by 3, obviously there's going to be a remainder of 1. So let us now use the modulus operation, which is going to do the division, but this time it's going to give us just the remainder. So we're going with 10 and 3 again. We're using the modulus operator. And what I'm getting here, I'm not anticipating that. So I still end up with the 3.33, which means that there's something wrong with my code. I have some logical error that I need to flesh out. So let's go back to the code and have a look. And if we look at line 17, note that line 15 and line 17 are actually making use of the same operator. And that's the reason for the logical error. So I'm simply doing a normal division for the modulus when I should be using the modulus operator. So let's address that. So I've now fixed that by putting the modulus operator, and we can now retest. So it's 10, it's 3, it's the modulus operator, and we're now getting what we expect. So when we divide 10 by 3, the remainder is actually 1. All right, great. Let's now make use of the next division symbol, which is the 2 forward slash. So let's copy, let's paste. This time we are looking at the double forward slash, and we are updating the result line as well. So it's 10, it's 3, it's the double forward slash, and the answer that we end up with in this particular case is 3. So how did we end up with 3? If we divide 10 by 3, then 3 goes into 10 3 times. And that's why we end up with the 3 at that spot. So it goes into 10 3 times, and the remainder would be 1. That's why when we use the modulus operator, we get the remainder, we get 1. And when we use the double forward slash, what we're going to get is the quotient. In this case, the quotient is 3. Just to be absolutely clear, let us do another example. So 10 and 5, and let us use the double forward slash. And the question is being asked now, how many times can we divide 10 by 5? And the answer is going to be 2, which means that 2 is going to be stored inside the result. So let's test that. And judging by the output, we are indeed getting that. So we are getting the 2 as we anticipate. If we were to do the modulus operation using these two numbers, then we would end up with 0. Because 10 divided by 5, we get 2, and the remainder is going to be 0, because there's no remainder that is going to be left. So 10, 5, this time we're using the modulus operator. And our output is actually 0. So in terms of finishing up this particular solution, I think the only thing that we have left to do is the exponent. An exponent simply means we are raising a number to a power. So let's add that. So copy, paste. This time we are checking for the exponent operator, and we are also going to apply the exponent operator. Now I'm going to use simple numbers when I'm testing this, so that we can see at a glance whether or not our program is working properly. So let's enter 3 and 2. We're going to choose the exponent operator, which means that we're going to be saying 3 squared, or 3 raised to the power of 2, which gives us 9. 3 times 3 is equal to 9. And the output is actually giving us 9 as we intend. So just having a look at what we were up against, we were to ask the user for 2 numbers, which we did. We were to ask the user for an operation, which we did. And then based on the operation that was selected, then we made use of the multiple if statements to actually perform the calculation that was necessary. Now, if you note carefully, in this example, we use the multiple if statement, and these would be multiple single if statement. As I would have mentioned in a previous video, the challenge with this is that each of these if statements will be checked as this program executes. And that is going to be a little bit inefficient, because once we check the operator and we find the operator that we are looking for, then we want to perform that calculation, and we want to ignore the rest of the if statements. If we have things organized like this, then the rest of the if statements are not going to be ignored. They are still going to be checked, even though they don't need to be checked. And so what we're going to do next is we're going to convert this to the else if construct, which is a bit more efficient in that once it finds the condition that is true, it will execute those commands that are associated with that particular condition, and then it will ignore the rest of the ifs that are present within that construct. So let's convert this, and then we move on. All right, so in terms of doing the conversion, we are going to change all of the if statements that precedes the first if statement to else ifs. So notice the only one that is going to say if is the very first one, and everything else is going to have elif. Remember, elif means else if. And I'm also going to add an else. And for this else, I'm going to simply do a print statement that indicates that the operator or the symbol that has been chosen is invalid. So just to explain here, the only time we would reach the else is if all of the preceding conditions were checked and they were actually false. So if we have checked all of these statements and they are false, then that's the only time we would actually reach the else. So let's clear our output and test that. I'm going to start by entering an invalid operator. So let's say 10 and 3. And let's say that the operator is going to be the $sign. So I'm going to hit enter. And notice we get our message that indicates that our operator is indeed invalid. Note, however, that we have still done our print. And we have done our print because our print statement on line 26 is not linked to any condition. And because it's not linked to any condition, it means that line 26 is always going to be displayed. In case that's not the kind of look and feel that we want, then we would have to put in some codes to address that. So let's quickly just add some code here on the fly to address that. I'm going to introduce a new variable. I'm going to call this variable print it. You would have seen me use this before. And let's treat it as a Boolean. And let's say print it is equal to true. That is the default of print it. However, if we have an invalid operator, then let's set print it to false. And let us wrap this print statement. We're going to wrap this print statement inside a conditional. So if print it is equal to true, then let's print. And what this also tells us by extension is that if print it is equal to false, then we will not be printing this line. So let's try that out. So 10, 3, the operation we said is the $sign, which is invalid. And this time, all we get is the message that says invalid operator. We're no longer displaying num1, num2 operator and result. And this is the kind of manipulation we can do as we architect our solutions. We can have a look at the output And then we can put in our construct so that we can determine the kind of look and feel that we want in terms of our user interface. Let's now try out one of the operations, one of the valid operations. So let's say 10 and 5. And let's say we want to multiply. So 10 times 5, that gives us 50 as we anticipate. Let's just try one more. This time, let's say 10 and 3. But this time, let us do the exponentiation. So 10 raised to the power of 3, that's going to give us 1,000. And we are indeed saying that we have obtained the 1,000. So for all intents and purposes, the code is working in a similar manner as before, even though we have swapped out the if statements with the else if command. And this gives us a more efficient program, as we mentioned earlier. So this is it in terms of this particular solution. So let's have a look at another challenge. So let us try this one, the rectangle, area, and the perimeter. So we need to ask the user for the length and the width of a rectangle. And we're given the formula for the area and the formula for the perimeter. So the formula for the area is going to be length times width. So let's do that first. And then after that, we tackle the perimeter. So let's get rid of everything so that we start to write from scratch. So we need to accept the length and the width. So length is equal to int input enter length. And we're going to do something similar for width. So width, and we need to ensure that we update our prompt. And then it says that the area is equal to length times width. And let us do our formatted print, where we're able to see what the length was, what the width was, and what the area is. And let's put a message before it. So area is and let's test that out. So let's enter the length, 5. Let's enter the width, 3. And the area is 5 times 3, which is equal to 15. So that's what we're getting as our output, which is indeed correct. Now, in terms of how it looks, I think I want to change that. So instead of using that symbol, I just want to have the colon. I think the symbol looks a bit too cluttered. Let's go again, 5 and 3. So area is 5 times 3 is equal to 15. I think this looks a little bit cleaner. So we have calculated the area. We now need to calculate the perimeter, which is going to be 2 times length plus width. So let's call it peri for perimeter. That's equal to 2 times, and it says length plus width. So let's use our same values, 5 and 3. So 5 and 3, if we add them together, length plus width, that is going to give us 8. And 8 times 2, that's going to give us 16. So we now need to print the perimeter. The perimeter is, that's going to be 2 times length plus the width in brackets. That's how I want it to be displayed. And that is going to be equal to peri. So let's clear, execute with the same numbers, 5 and 3. And now we just want to focus on the perimeter itself. So it's 2 times 5 plus 3. That's the length and the width. And the output, as we had calculated previously, is actually 16. So please note, we have made use of all of the arithmetic operations, so you should understand how they work at this stage. We have made use of the assignment operator. And I think now is an opportune time for us to have a look at the additional assignment operators that we are provided with. And we're just going to look at them in terms of the concept. So to make this simple, I will get rid of all of these. And I will simply use arbitrary variables. Let's call it X. And let's call it Y. So these are just arbitrary variables. So I'm going to get a value X from the user. And I'm going to add 5 to the value in X. And then I'm going to update X. So that is what this is actually saying. I'm going to look at the current value in X. I'm going to add 5 to that value. And then I'm going to update X with the new value. Then let's just print X. Let's just a formatted print. And let's say updated X value. And we display what that update is. So let's execute. It says enter length. So I probably should have changed that to enter X. And let's say enter Y. I'm not using Y as yet, but I will soon use it in terms of our demonstration. So enter X. That's 10. I'm entering Y, which is 2, not being used. The updated X value is 15. Why? Because the original value of X is actually 10. So 10 plus 5 will give us 15. And we are then going to update X with that value 15. And that's why we are seeing that the update here is actually saying 15. So that's pretty straightforward. That's what you would have anticipated. We could have also said X plus Y. And this is where we now introduce Y into the equation. So let's clear the output. Let's re-execute. So it's 10 and 2. which means we are going to have the value 10, which is x. We're going to add the value 2 to it, which is y. We end up with 12. Then we are going to update x with that value 12. So let's see if that is what we're going to get. And based on our output statement, we are indeed getting that. Now, I'm going to comment out this line. You see what it does. And I'm going to write a new line. I'm simply going to say plus equal y. So we had entered 10, we had entered 2, and note we are still getting the same output, 12. So what is happening here? This is a shortcut way for us to update a variable. And we're updating the variable by making use of a calculation. So in other words, this statement that we're looking at is actually equivalent to the statement above. It's just a different way of writing it. And as you can see, it is more concise because we have eliminated the need to write x 2 times. So x plus equal y is the same thing as saying x is equal to x plus y. And that's all we are doing. So you will find that there are several shortcut operators like that, and you would read them in the same manner. For example, if we had multiplication equal instead, then what this is saying is that x is going to be equal to x times y. And then we are going to update x with the result of that computation. So let's try this out. So let's say that x is 3, and let's say that y is 2. Then x star equal y is going to be the same thing as x is equal to x times y. So x times y, 3 times 2 is 6. The updated value of x is therefore going to be 6. So when we display the updated value, we should be seeing 6. So let's hit the enter key. And we are seeing that the updated value is indeed 6. And once you understand what I've just explained, then you understand how to use any one of these operators that you're seeing here. Just as a reminder, it's a shortcut way or a more concise way of performing one of these operations. And the aim is to always update the variable that we have on the left. All right, so this has taken us to the end of this particular session. And as you would have seen, we have put all that we have learned so far into use by virtue of solving some problems. So you will get your worksheets and you are going to be asked to use these same concepts and apply them to the solutions as you craft out possible solutions for your worksheet. All right, so take care and look out for the next one.